All right, so let's continue with permutation. So this time around, we'll talk about permutation of digits. The first question we solve said, how many 4 digits, how many 4-digit numbers can be arranged or formed, can be formed with the digits 1 to 9, 1, 2, 3 up to 9. Okay, if I question said repetition is not allowed, repetition are allowed. Okay, repetitions are allowed. Repetitions are not allowed. The last digit must be even, and repetition is not allowed. The last digit must be even, and repetition are not allowed. Okay, so let us solve that. Now, if repetition is allowed, number one, watch. If repetition is allowed and I want to form just 4-digit numbers, okay? Now, to form the first number, I can use any number I like. I can use 1, I can use 2, I can use 3, I can use till now. So I can use 9, okay? In 9 ways. The arrangement, in fact, the arrangement is equal to, for the first one, I can use 9. Okay? I have chosen 1. Now, if repetition is not allowed, which means I'm left with 8, but repetition is allowed, so I can use any of the 9 of them again. In the third one, I can still use any of the 9 of them again. In the first one, I can still use any of the 9 of them again. Okay? So if repetition is allowed, it simply means the number they are raised to power that's 4. That's all. The number of items raised to power the how many you are forming. Okay, as simple as that. So the next one, watch the next one now. The next one simply said, where is the next one? Okay, this one said that what repetition is not allowed. So to form the first one, the arrangement becomes, to form the first one, we have 9 of them. You can choose any of the 9 of them. And we have chosen 1. And that one that you're choosing, we cannot repeat it. So we are left with what? 8. We can use any of the 8. Now we have chosen 2 that we cannot repeat. So we are left with 7. We are choosing 3 we cannot repeat. We are left with what? 6. As simple as that. Very simple. So number what? Number 3. Okay. Number 3 said that the last digit must be even. If the last digit must be even, normally, watch. If the last digit must be even, to choose the first digit, no restriction. We are choosing any of the 9, correct? And they say no repetition. So we are left with 8. We choose what? 8. Okay? No repetition, no. We choose what? 7. Then they say that the last digit must be even. So, okay, sorry. If the last digit must be even, so let us choose the last digit first. To choose the last digit, to choose the last digit, I can only use 2, 4, 6, 8. Okay? So to choose the last digit, I can only use 4. 4 people. Okay? We can only use 4 people to choose the last digit. Now, and one is already chosen. Okay? Times, to choose the first digit, since I've removed 1 from the last digit, I have 8 remaining. I've removed another 1. I have 7 remaining. I've removed another one. I have 6 remaining. So I'm left with this. Okay? So that is that. I decided to choose the first digit first because that is where there is a condition. So this is for the last digit, then first, second, and third digit. So multiply it and then that is your answer. I hope you understood that. Let's take another question. Number 2. Number 2 said, how many numbers greater than 4,000, okay, can be formed using sum or all the digits, 6, 5, 4, 3, and 2. Okay, without repetition. Okay, now to form the first digit solution, to form the first digit, and we need a number that is greater than 4,000. If I use 4 can work because 4, 2, blah blah blah, 4 can work, but 3 and 2 cannot work to form the first digit. Okay, to form the first digit, numbers greater than 4,000. Okay, the numbers are formed, all 5 digits will be greater than. Okay, we are forming any 4 numbers that is greater than 4,000, but they don't tell us any digit number, so we can even use the 5-digit number. So if you want to use the 5-digit number to form any number that is greater than 4,000, it's just 5 factorial. So using the 5-digit numbers, okay, it will now be just 5 factorial. That is, we can use in fact, anyone you use here to form 5-digit number, it must be greater than 4,000. So now, if we want to use 4 now, using just 4-digit number, now if we want to use 4-digit number that is greater than 4,000, we can. I hope you know we cannot do 3 because there is no 3-digit number that can be greater than 4,000. So the first number we cannot use 1 and 2. For the first number we can only use 6, 5, and 4. Okay, 6, 5, and 4, which is what? Which is just 3. We can use 3. That's to form the first one. Now you have formed the first one and there is no repetition. In the second one, we can use any of the 6 numbers, but since we have taken 1, okay, so we are left with 5. We can use any of the 5. Okay, because there is no repetition. Now for the third one, remember you are forming 4-digit number. The third one you can use any of them, but we have already taken 2 out, so we are left with 4 times the last one. We are left with 3. So my answer becomes this one first. The arrangement. I hope you know we cannot do using 3-digit number. We cannot use. There is no 3-digit number that can be greater than this. That's why we stopped here. So the arrangement is simply 5 factorial. The one of 5 when you use 5 plus the one when you use 3 plus the one when you use 4, like that. So the one when I use 5 plus when I use the 4, which is what? 3 times 5 times 4 times 3. So what do we have? I'm having 192 ways. 192 ways. Okay, so that is that. So the next one, how many how many 4-digit numbers? They have already told you how many they are. 4-digit numbers. How many 4-digit numbers greater than 5,000 can be formed using 1, 2, 5, 6 and 7. No digit can be repeated. If no digit can be repeated. Solution. Now, they have already told you how many digit number you are forming. So, we are using 4-digit numbers. 4 digits. Now, the only 4-digit number that can be greater than 5 any 4-digit number that can be greater than 5,000 must start from what? Must start from what? Okay, it can start from 5, start from 6, start from 7. So at the first one can start from 5, 4, 3. What am I saying? 5, 6, 7. They can never start from 1 and 2. Okay, so I have what? Three ways for that particular one. Times I've chosen the first one. So to choose the second one, any of them can work. So how many are they? 1, 2, 3, 4, 5. But I have taken 1, so I'm left with 4. Times the next one. Any of them can work, but I have taken 2, so 3. Times the next one. Any of them can work. Since I've taken 3, 2. So my answer is now what? 72. 72 ways. As simple as that. I hope you understood that. Okay? So, let's move into permutation of letters. We have talked about permutation of digits. So now let's move into permutation of letters. Permutation of letters. Okay. Now they say out of the letters A, B, C, P, Q and R. How many arrangements can be made? 1. Beginning with capital letter. Beginning with the capital letter II. Beginning with, okay, ending with capital letter. Okay, beginning and ending with capital letter. Solution. Okay, for the first one, they say that we are to begin with capital letter. If we are going to begin with capital letter, which means out of the letters this, how many arrangements can be made beginning with capital letter? Okay, that is, I can begin with A, I can begin with B, I can begin with C. Okay, now I have 3. These are the things I can begin with. Okay, now, but how many letters are we having? 1, 2, 3, 4, 5, 6. We have 6, but I have chosen the first one, which is the beginning from these 3. Okay, so I've taken 1, so I'm now left with 5. So it's going to be what? Times 5 factorial. Or do I make it clear for you? Let me make it clear for you. Watch. To choose the first letter, they say we should begin with the capital letter. So I can begin with either A or B or C. So they are 3. I can begin with any of that 3. I have taken 1. Now how many are they? 1, 2, 3, 4, 5, 6. 6 letters. I've chosen the first letter. Okay. Now to choose the second letter, how many are they? 1, 2, 3, 4, 5, 6. I've taken 1. So it's remaining what? Maybe I chose this one. It's remaining 5 now. So 5 to choose the what? The second letter. The third letter I've taken 2, 4, 3, 2, 1. That is why I say that it is what? 3 times 5 factorial. Okay? As simple as that. Number 2. Now, For number 2, for the first one, let us analyze it. For the first one, I can choose any of these 3. If I choose any of these 3 for the first one, okay, and for the last one, I can choose any of these 3. But since I have chosen, what am I saying? Since I have chosen 1 already out of it, so it's meaning 2. So for the last one, I have only 2 options to choose. Are you getting me now? Then those in the middle, since I've chosen 1 for the first one and 1 for the last one, so I'm now left with how many letters? Out of the 6, I'm left with 4. So, but in the one in the middle, I can use any of the 4 of them. I can use any of the 3 of them. How many? 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Correct. 1, 2, 3, 4, 5, 6. Remaining 2. 2 times 1. Okay. So, what is now my answer? My answer is what? 3 times 4 factorial times 2. So, what do I have now? So 3 times 2 will give you what? 6 times what? 4 factorial. So that is the answer. I hope you understood. I can fill the board. So it's simple thinking. So the next one said how many words? Okay, how many ways? How many ways can the letters of the word chemistry be arranged, comma, if the vowels must always be together. Okay, if the vowels must always be together. Now the vowels we have here are what? E and I. So if the E and I are going to be together, watch, I'm going to have CH, E and I being together as one. So I'm going to have MSTRY. Okay, so now the ways of arranging E and I is just 2 ways times. Now how many are they? 1, 2, 3, 4, 5, 6, 7, 8. Remember I counted this one now as 1. Okay, that is 8 factorial. So that is that. The next one, I can go in here. The next one, how many words can be formed? How many words can be formed? Okay, from the letters A, E, I, O, Y. Okay, sorry. From the letters V, A, L, E, valedictory. Okay, provided that the letters A, E, I, O, Y are not together. Sorry, okay, are not to be separated. Are not to be separated. Okay, solution. Now, first of all, since they are not to be separated, we are going to keep them in one place. So I'm going to have in fact, since they will now become 1, okay, the number of ways of arranging them normally is going to be 5 factorial. This one now, 1, 2, 3, 4, 5 factorial. Now how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the remaining one should now be what? 11 minus that 5 that I've already taken, factorial. So my answer is simply 5 factorial, 4 factorial. That's all. Okay? I hope I counted it well. Sorry, this minus this is not 5 minus this is 6 now. 6 factorial, sorry. 6 factorial, okay? So what am I saying? Sorry about that. This one is 1, 2, 3, 4, 5. That is 5 factorial. Remember, I'm not counting this one as 1. So I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 11. So since I'm counting it as 1, let me write it out so that I will not make mistake. V, then that A, E, I, O, Y as 1. I've already written A. So L, D, C, T, R. So how many are there? 1, 2, 3, 4, 5, 6, 7. Okay, so it should be times 7 factorial. Sorry. So this is the answer. 5 factorial, 7 factorial. Okay. So the next one. How many? The next one. How many different words can be formed? How many different words can be formed with the letters of H, A, R, Y, A, N, A. Okay? I, you say, how many of these words have H and N? Okay, this is the first question. Okay, so this is the first question. So the second question now said, how many of these words? How many of these words? How many of these words have H and N together? The third question. How many of these words begin with H and end with N? How many of these words? How many of these words begin with H and end with N? How many of these words begin with H and end with N? Okay, so first of all, the first question A. Okay, let me keep solving here. The first question A says, how many words can be formed using the letters of this? How many are they? 1, 2, 3, 4, 5, 6, 7. I have 7 factorial all over. H is 1. A is 1, 2, 3. So I'm having 3 factorial. Is there another one that is like double or 2? Okay, that's all. Because the other one should be 1 factorial, 1 factorial, 1 factorial, but 1 factorial is still 1. So I'm left with this. And this divided by this is what? 7 times 6 times 5 times 4 times 3 factorial all over 3 factorial. 3 factorial cancel 3 factorial. I'm left with 8 fourths. Then B question. Okay. Now counting H and N as 1. Counting H and N as 1. The number of ways of arranging them normally should be what? 2 factorial. Hope you know. Times. Now we are not left with how many words now? We are left with, watch, we are left with H and N. H and N as 1 word. We are now left with A R Y A. Okay, so which is what? 1 2 3 4 5 6. 6 factorial all over. A is 3 factorial. So I'm left with 2 times 1 times 6 times 5 times 4 times 3 factorial all over 3 factorial. 3 factorial take care of 3 factorial. I'm left with 240. See? Calculate it well. Am I missing it? Where is the question? What? Yes, 240. Okay. So the next one said that what? How many of the words start with H and end with N? So the beginning is H, 1 times is just one way. The end is H again, 1. So I'm not left with how many now? How many are they now? I'm not left with finding the remaining 5. I've gotten 1 and 1, remaining 5. So they are now 5 factorial all over. There is a repetition of 3 factorial. So that is just my answer, which is 20. Okay, so that is that. Now let's talk about arrangement, role arrangement permutation. Role arrangement permutation. Role. Role arrangement permutation. And I think that's the last one we're going to do before we enter combination. Let me check my time. Okay. Role arrangement permutation. They said 3 boys. The first question. Three boys and 4 girls are to be seated in a row. How many ways can this be done? How many ways can be if the boys are to sit in the middle? If the boys are to sit in the middle. Okay. Now the boys are to sit in the middle. Now, which means let me represent it with A, B, C, D. Okay, no. A for the boys. For the girls, for the girls, okay? Or B, okay? B for the boys. G for the girls. Now, if the boys are going to be in the middle, normally there are 3 different ways of arranging them in the middle, which is 3 factorial. That is putting them in the middle, okay? Now, arranging the girls, we have 4 of them, but we are going to arrange them in two ways. 2 at the edge, 2 at the other side. So it's going to give me 4 permutation 2. Okay? It's going to give me what? 4 permutation 2. And 4 permutation 2 will give me, that is 4 factorial all over 2 factorial, which is what? 4 times 3 times 2 times 1. 4 times 3 times 2 factorial all over 2 factorial. That is 12. Okay? That is 12. But if you don't want to do it that way, there's another way we can do it. Okay? Or let's just take it like that. Times what? 4 permutation 2. So the boys in the middle, and then the girls can be arranged. 4 of them can be arranged in 2 seats left for them. Don't forget that. Look at what I'm trying to say. We have how many seats? We have 2 seats here for the girls, 2 seats here for the girls. Okay? And there are 4 of them. So which means 2 people can be here. The other 2 people will be here. or 2 people can be here, the other 2 people will be here. So which is what? 4 of them being arranged, only two seats for them, like 2 space for them. Let me call it 2 space for them. 4 of them, but 2 space for them. Okay, that is 4 permutation this. So that is just your answer, which is what? 3 factorial times 4 factorial all over 4 minus 2 factorial, which is 3 factorial times 4 times 3. So that is that. Get your answer and we are okay. So everything gave us 72 ways. The next question. The next question said 10 different books are to be arranged in a row on a bookshelf. On a bookshelf, comma, which can take only 7 books if 2 of the books are to occupy the ends. Okay, how many ways can this be done? Okay, now we have each of the books to be arranged at the one end, so they have 2 ways of arranging them. Okay, that is, they have 2 space to arrange the 2 books. That is, first of all, 2 factorial times. Now, how many books are they? 10 books. We have taken 1 in this side, 1 at the other side. So I'm left with 8. Since I'm left with 8, and that 8, okay, they said I'm left with 8 permutation. The space they will now occupy is now what? 7 minus the 2 that's already taken out, which is 5. So which is what? 2 factorial times 8 permutation 5. As simple as that. Okay. The next question. This one said, in how many ways can 3 boys and 5 girls be arranged in a row so that all the 3 boys seats are together? Solution. Now, if the 3 boys are going to be together, okay, look at it. Let me have the boys. Boys, boys, boys being together. Then the girls, 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 girls. Okay. Now, how many are they? 1, 2, 3, 4, 5. This one has 1, 6. But before then, these people can be arranged in 3 factorial times then the 6 of them. I hope you get that. So that is just the answer. So get the value of that and then you are done. Very simple. So I think the next thing we will now do is permutation. Permutation. Okay. Okay, take this assignment. 6 men. 6 men and 2 women. 6 men and 2 women are to be seated. Are to be seated on reverse. On reversed seats at a conference. If the seats of the 2 women are labeled with their name. In how many ways can the group be seated? Okay, so that's the assignment. So just solve it and drop the answer at the comment section. Thank you very much for watching. Please subscribe. Please subscribe.